Yeah, so the slides are on there. This next one is a generic sort of a core project overview that I've butchered from various different sources and added a few slides myself because it's been quite an online community, a lot of Vimeo videos in there. So the sooner I think we can get through this bit, we'll have the building blocks for figuring out what is a smart legal contract and how do you build one. And then we can start looking at how you get started and build your first one. So let's resume. Again, keep things going in the chat. Love to see any suggestions on any candidate clauses. Let's not try and bite off the entire or boil the ocean. Let's try and not implement the entire NEC or JCT contracts. But if there are some specific ones that are in there, I think it would be wonderful to try and address those. Again, the weather one, maybe let's not look at that one because we'll be looking at it in a bit more detail with the team from EHAB and use that as a worked example. I don't know if the team are on here. If you are, if any of the guys have actually joined, feel free to pitch in. If not, I can kind of go through it when we start to hit the Oracle section. But before we get into the oracles, I'd love to get into your question there in more detail. So it's a very important aspect for blockchains in general, but also for legal smart contracts is a source of truth or a trusted provider of data. Or, as we mentioned, a potential fixer of problems where things have got out of whack and how do you trust or how do you turn something that was not computable into an event that then needs to be computable. So we're going to resume with what is the Accord project. So it's a non-profit organization, first of all, so nobody is kind of charging for the Accord project. As I mentioned, there are software vendors out there. I forget the name of Martin Halford's group in Australia, but they're a provider of tech in this space as well. But Clause.io, one of the main providers in there. But the core concept itself is free. It's available for anybody to use, non-profit, and it addresses, again, lack of common approach for smart legal contracts, widely divergent, partially incompatible, or very vendor specific in certain areas. So everything we do is in the open. So we try and contribute back changes that we do. There is a process around that. It is quite a rigorous process, like any open source project. You can't just kind of throw stuff out there. Things are reviewed, there's code reviews, lots of documentation around this. I have some guides on it, and having done this again recently for contributing some stuff, there's a few hurdles to get through, but it really does improve the quality of the code and making it more common for developers to work with as well. So we've had quite a number of contributors to it. We have just some internal bits. There's a technology working group call, nice and late every Wednesday. For me, it's now 10 p.m. in the evening, so I'll be back on the call tonight to talk about some of the results of this because they were keen to see how this was received, and I'm really very interested in getting anybody in this workshop to please consider joining the calls. You don't have to be part of the group. It is an open community, so anybody is welcome to join. If anybody wants to join tonight or another time, please do let me know. We recently had a technical steering committee election, which is something that had to be formed when we joined the Hyperledger community. So I was lucky enough to be elected to that, and I'm very excited to be part of the technical journey of this and how do we bring this forward. And it's probably a very good time for the project at the moment because people are really starting to get interested in this space. There's a number of companies involved in it, both from blockchain providers to law firms to everybody else in between that you can imagine. Some are more active than others, in fairness, but as it typically is with these things. But there's a number of different working groups, a number of different topic areas, etc. So I don't even see all of the communication that goes on. We have quite an active Accord project Slack, so there's 20,000 people registered on there. Not always active, of course, but a lot of lurkers who are kind of seeing how the project develops, etc. So let's jump into the bones of it. There are kind of three major parts. I've mentioned the template library and model repository. These are existing places to go for existing contracts and clauses and models as well. So data models, different types, etc., or things that people have built. So those RIC schemas, for example, or constructs that exist within NEC or JCT contracts. That's where we'd love to get contributions back into that. And EHAB have started that process, and we've done a little bit as well. So we'll come to those a little bit later, but that's generally a good place to start. But we're going to start to look at the three main aspects for the Accord code base. Again, it's not trying to map natural language directly to code. As I mentioned, there are companies trying to do that, but it tries to do it in stages. it's quite good that some of the, well, okay, let's start here. So Concerto is our object definition. So any of the terms that are defined inside a contract will have a mapping with a variable name and a variable type. And it could be a simple type, like we saw strings or numbers. Numbers could be integers or floating points, or they could be amounts, and amount can have a currency value, etc. So all of these different types that are there, that is just one standalone piece of the puzzle. So you don't have to take the entire project in its as an entire unit. There's value just in the natural language piece, there's value in the data types, and yes, you can have executable clauses that run in Ergo, and Ergo can then be cross-compiled into JavaScript, so it can run on a Hyperledger environment. It can be cross-compiled into Java or Kotlin and run inside a Corda environment. And yes, there has been some work, not directly to Solidity, but WASM, which WASM, or WebAssembly, some of you might have heard of in the web world, is trying to be a new equivalent sort of language to JavaScript, but a far more secure language, runs in a sandbox, much more low level. So it's more like old school C than moving up the chain. But we've been doing some work with an intern basically during the summer who's done some very good work at cross-compiling Ergo into WASM. And that will allow us to deploy into even more different types of blockchains. So substrates and maybe eventually Ethereum as well. But it'll be kind of future Ethereum 2.0 and beyond. But that's kind of our strategy for Ethereum. There are some ways of interacting with Ethereum. Maybe you covered this in your smart contract workshop this morning. You saw that events can be emitted on chain. Well, clause, another thing that they would do, and it doesn't necessarily need to be clause, it can be implemented with any Ethereum client. You can connect to the Ethereum network, you can listen for these events, and then you can take action on your smart contract. And then if you've got an Ethereum client, you can emit events back on chain. So the logic doesn't necessarily have to run on chain, it can run off chain, but it can respond to incoming events and emit its own events back on chain as well. So there's lots of flexibility. We want to try and target multiple different systems. So just to get the terminology. So Concerto is the data model. Cicero is the structured templates. So you start off with a template where you have variable names in there. So you see shipper and receiver and deliverable. And then when we have an instance of that, then we will start to fill out, well, who is the shipper in this case, and who's the receiver, and what is the deliverable? And that's where we start to have an individual part of a contract. Just like when drafting any contract, a lawyer will start with, in many cases, a Word document with some sort of placeholders in there, and then start to add in names, etc. So Cicero can be very useful for contract assembly. And it may be that a contract is not necessarily a fixed document. There may be multiple variants of clauses depending on how sort of defensive or offensive you might want to be, or it might be something that's agreed at negotiation. So there could be variants of that. So having it as a computable document is quite useful. And even just companies keeping track of what version of a contract that they have with what supplier at a point in time can be a bit difficult in a non-digitized environment as well. So even just having Cicero and tracking, a bit like version control for this stuff, you'd be surprised at any sort of low-hanging fruit you can nip off when you're trying to look at how existing systems work. So Cicero is looking at the natural language aspects. Ergo then is the kind of logic behind it all. So you've defined what the variables are. Let's say here shipper and receiver. Those get mapped in Concerto to a data type, and it could be a complex data type, or it could be a collection of attributes, a bit like in an object-oriented world for code. You have a class with attributes. And then the Ergo is the logic piece. This is what implements the logic behind the clause. So that can respond to requests, and it can generate responses. It's not a million miles away from the concept of web request, in this case, where you have a website that maybe somebody fills out a form, that gets submitted, and then you get a result back afterwards. And in fact, when you start to look at some of the implementations in Corda, for example, that's how it works on chain anyway. You have a web interface, somebody fills out something, just like they did before. They don't need to know that there's a blockchain behind it. They don't need to know that some of this business logic is running inside the legal smart contract, for example. They just are interacting with a website just like they always did. That doesn't necessarily mean that they need anything like MetaMask or anything like that. We're not talking about dApps in that space. We're talking about a piece of logic that takes inputs and can return a response in this particular case. So Ergo enables the business logic expressed over the variables from your contract in response to real world requests coming throughout the contract's lifetime. The lifetime of a contract is something we haven't really spoken about yet, but it is an interesting one. We've spoken a little bit about upgrades, etc., but it is an interesting piece as to how long does a contract run for and what can start it, and what can kill it, what can move it into different spaces. Okay. VS Code extension. So anybody who's in a Windows environment, or you can do it on Mac as well. We have a project extension written by Dan Selman, which can make things easier for the syntax highlighting and so on. So you don't just have to use something like Notepad for generating these types of things. And that can be very, very useful for finding any syntax issues, compilation errors. And some of this is quite nuanced in that one white space can knock things out, just like it can do in some cases with programming languages like Python. You get one white space or a tab in there, it messes up the entire thing. But that's necessary because a lot of this is based on hashes. So if you have a contract where you've got aspects of a contract which can be edited, and they're supposed to be edited, like those rates, etc., where you've got those variables inside there, you don't want anybody going in and subsequently trying to modify something else on the contract that they're not supposed to. So that's why hashing is used quite a lot in this case. So even, as we know, one small white space that is not seen by a user, that will knock out the template logic, because it's either valid or it's invalid. There is no kind of halfway between the two. So the hash is either valid and the contract matches except for those particular templated variables, and those variables need to be of the right type as well. So the VS Code extension can help you with that. There's absolutely no need for you to go and install it though for this workshop if you don't want to. Outside of that, we have other authoring environments. We actually have a Word plugin as well, which I haven't mentioned in here. There's a new version of that. And again, another intern was working on that over the summer. It looked pretty good. I haven't tried it. I tried the old version, but there was a lot of plugins in my Word environment, and not a big fan of Word anyway, so it was causing issues, but it wasn't, it was more of a general Word issue really, and Microsoft and lockdown computers, etc. But we can go completely online. We have web components, so you can embed the contract authoring inside your own tools. So you don't have to use the online templating tool, which I'll point you to in a minute, that's hosted by Clause. You can embed that in your own tool. If you have an existing contract editing solution, you can do it there. You could potentially embed it in a Webflow in your existing blockchain solution. So for example, the Corda demo we'll look at a little bit later, it's got a web interface. You could easily add some of the highlighting, syntax checking, etc. into that. It's just web components. It uses React, and it's quite modular and yeah, quite flexible actually in what you can do with it. This is a new aspect for the project, and it's a very welcome addition. It really improves the authoring experience. And some of the older examples that you'll see are flat text, but now obviously we support what's known as Common Mark or Cicero Mark and Template Mark, which we'll get into. But Common Mark is a kind of an evolution beyond Markdown. So we can start to do fancy formatting and tabular data as well, because certain contracts might have a rate table or something. Well, you can represent that in this table as well. So these three pillars really make up a smart legal contract in the Accord model. Again, there's a nice article on document assembly to computable documents that's been written by Clause. I suggest you, if you want a little bit more of what is the kind of idea behind it, then we can start to drill into that. Okay, so this is our normal sort of, once we get past hello world, this is our kind of normal real world teaching example, the late delivery and penalty. So in this case, it introduces the concept of a buyer and seller. So these are the parties. So there's a specific object type, if you like, in Accord called a party, because every legal agreement needs one or more parties. Sometimes they're known, sometimes they're unknown, but you know, unilateral or multilateral, etc. But in this particular case, it'd be two named individuals or companies. So a buyer and a seller. So there'll be a penalty amount to a percentage penalty of the total goods for every X number of days, for example, that something is going to be delayed. But to make it a little bit more complex and a little bit more like the real world, that might be capped. So for example, if it's so late that, you know, and you could argue why it's late is as a result of a storm or something, that's where the guys at EHAB could be quite useful in putting an additional clause to try and figure out if that delay was foreseen or unforeseen or justified or an exceptional event or something. But we can start to add these types of additional constructs in there. So it's not just simple calculations. We can actually do far more complex events as well. So you can cap at a particular percentage value of the contract. And then if it's more than a particular period of time, then maybe the buyer is entitled to terminate the contract. So that brings us into this contract life cycle that we spoke about before, as to how long does the contract exist for and what types of things can terminate it. And if it can be terminated, how does it terminate and who's liable, or is there a payment to be made, etc. So we'll be looking at that in a little bit more detail as the code behind it in a little while. So the stage that happens after the authoring is that all of those variables get turned into a data model. And in this particular case, this is the underlying Cicero for that. So we have a construct called the accord party for the buyer, the seller. We got a duration for the penalty duration. So that's a number of days, weeks, months, hours. And we have some very good time libraries in there for figuring out time zones and all this kind of stuff that's a bit messy when it starts to come to date processing. And then we got doubles to represent the penalty percentage, and a cap on percentages as well. We have constructs for currency in there too. It's not in this one. And in fact, I've modified this one a little bit to do a currency example, which involves a currency conversion from an oracle. But we'll get onto that a little bit later. And then the duration is maximum delay here. So for example, your duration could be 15 days. So what does an instantiation look like? Well, the seller could be Steve in this case, or it could be an organization as well. How does that map into the code? This is really what the developers in the group want to see. What is this strange looking language that's here? Well, it might look a little bit more like something you're already familiar with. It's more sort of C-like and JavaScript-like than it is, say, Python or something. So you have the kind of curly braces, etc. There's a whole set of stuff around the origin of the language and why it is how it is, but it is a functional language, so it's quite specific in how you do things, but that's designed specifically because it's not supposed to be a general purpose programming language. Okay, you won't be building full blockchain solutions in this. It's not designed to be. It's specific for one purpose of implementing legal agreements. So it's doing what it does best. It's not trying to do anything else, which is why to build a full system, you need other systems around it. You might need a blockchain, which can do the low-level transactions and all of the things that you can do in a general purpose environment or language. So let's have a look here. We've got some imports. So these are imported from models.accordproject.org, which I mentioned in the slides. So this is a place to look at to see what's already out there. We'll have a quick look at that in a little while. You'd be surprised. We actually do have quite a rich set of existing types, and it is growing, but we'd love more contributions to it. And then we have this late delivery penalty clause, which is going to get a request and emit a response, as we said. So the contract will be created. It's got the parties involved, etc. And then something has to happen. Something has to arrive, for example. So in this case, we're talking about late delivery. So when did it finally get there? That's when this clause is triggered. There might be a timeout, which could be, in this particular case, we don't do timeouts inside the legal smart contract. You would do, the external environment would provide that trigger in. Okay, it's to do with the stateful nature. You provide the state in, and the requests go in, but the contract won't do anything by itself. And it's deliberately designed that way. So for example, you might have a timer event set up in Corda. We did this for the land registry example, for example, people would agree an exchange and completion date that would happen all at the same time. And then effectively the contract would sleep until that date happened. It would wake up and it would check to see, well, is the money there? Has everything been signed? Is everything okay? Yeah, everything's okay. It's an atomic transaction. Then money transfers from one party to another. Land registry gets updated, the title deed, etc. all happens at the same time. So in this particular case, the contract will sit there until there is a request in to say that either the delivery has arrived or maybe there's been a trigger and it's gone beyond a certain period of time. And in which case we need to figure out how much the penalty is, etc. So this request comes in, and that's a particular object that we will create, and a late delivery penalty response, and it emits a payment obligation. So this obligation is a very specific construct for the Accord project. This is a particular thing as a side effect in one way of a transaction, which is many transactions might happen to clauses, and there might be incremental payments, etc. But ultimately, if there's something like a final settlement, or if there's a penalty that has to be paid, then you can emit this this obligation, which is a construct that says, well, party A must pay party B, or in this case, buyer and seller must pay this amount, and it's hard-coded here, in this case, to USD, but we could have picked that up from the contract as well. In fact, it's probably one of those things that should have been specified in the contract to make it a bit more generic. But let's say if this was a very US-focused example, then you would probably presume that all payments are going to be in USD. But we have constructs for cryptocurrency assets and different types of tokens as well. But normally this kind of stuff should be specified in the contract. And we have currency types that will validate that the USD is a valid currency. So this payment obligation is a little bit different from what you might see in a traditional smart contract environment or any other programming language. Really, normally you just return a response, but in this particular case, it will do an emission as well, a bit like generating an event on the Ethereum network. So the guts of, well, first of all, before we get into that, the first thing we always do is to try to catch any problems early. So catch any validation errors before they cause problems later on. So always try to be defensive in your programming, just like in normal smart contracts as well. We need to try to stop people doing things that they're not supposed to, or data issues. And again, the Smart Legal Contract Canvas captures some of these potential issues that you need to think about. But catch them early. Don't have a bunch of different if statements everywhere, kind of indented 4 or 5 lines deep, trying to consider all of the different possibilities. So if something's not supposed to be there or valid, you can set this enforce sort of keyword that's there, which is a bit like an assertion in some languages. So we need to ensure that, for example, date is before agreed. So if now is before the agreed time, then it's too early, etc. So some validation really on that. And then we can, there's an error handling set of logic there as well, where you can give hopefully meaningful error messages. So again, there's some enforcing. We haven't really spoken about force majeure just yet, complex area. We'll get into it around oracles a little bit later, but you might have some FM clause in there as well, where if one party is claiming that FM is in place, then all bets are off in this particular case. Now, in this particular case, it's just sort of relying on the contract's version of FM, which may come from the request. That may not be agreed. So just because one party says there's FM, that doesn't necessarily mean that FM is actually in place. And that's maybe where you need to get that from an oracle. And this relates to the kind of COVID stuff that we were talking about before, but a far more advanced example. But sticking with the basics that are here, first of all, that is not a typo. You see this is kind of there's a stylistic aspect for how this is read and written as well. So slightly different to the way that you might expect it, but it's for readability and trying to ensure that the style is followed. So the kind of guts of it are really figuring out what is the difference between now and the agreed time. And again, we've got these utility functions here for date, time, diff days in this case. We've got other ones for months and years, etc. And if there's a difference between what was agreed and the time that it actually arrived, then you need to calculate what is the penalty duration. So some of the variables are defined in the contract. So that's why you see contract.penalty duration. So those were not related to the transaction itself. The number of days late is to do with the transactional aspect, but the kind of tenets of the contract are set when the contract was created. So that's why they're at a contract level. So normally it's a combination of both. And then finally, is this particular payment capped? So was this specified in the contract? Maybe it wasn't, maybe it's unlimited, and maybe it's maybe capped at the value of the goods or something. So there's lots of different intricacies that you can play around with there depending on the legal agreement that the parties ultimately agree to. So that's a kind of a practical example. That's really what we're talking about when we get into the guts of it. How does this fit in with a blockchain? Well, this request and this response needs to be generated by something and processed by something else. So this could sit inside, for example, a Hyperledger chain code. And then you could be getting shipping notifications. It could be getting IoT updates. In the case of the Weather Ledger project, that's what they do. There's also some shipping examples, for example, where maybe an item is tracked with a barcode. When it's finally scanned in at a port, it might be a few days late, then, or at arrival on a construction site, it might have been there buried under something, but that's a whole other aspect. But yeah, figuring out where does this data come from is normally put on chain, and it's just at the point where, well, rather than implementing this particular logic inside the core network or Hyperledger or whatever it's running in, let's keep the logic closer to the contract that was agreed. Okay, a couple of questions that are in there. Will these obligations have legal binding? Well, that's, as I said, going back to the original statement on the enforceability of smart contracts. Yes, it appears that these agreements are just as good as any agreement that you would have with existing suppliers, etc. Like I said, there's still some case law on this, but the English government, English Law Commission, anyway, at least is looking into how this can be defined as being something that is enforceable. So yes, it's moving towards that, where it is an agreement as long as it can be argued that, you know, everybody was willing going into it. Is it a valid contract? Well, we're talking about consideration here. There is value associated with it. Then there are obviously things that you can put into an existing agreement that could invalidate it. If one clause is incorrect, for example, that can, in certain cases, invalidate the entire contract. That's a problem that you have with paper contracts. So if something was put into a contract that wasn't, that was against the law, for example, or could be challenged, then, for example, that can throw out the entire contract. There are clauses that you can put inside there saying that if one clause is invalid, then that won't invalidate the entire contract. That's where the lawyers get involved, and that's the kind of extent of my legal advice in this area. So again, this is something more for the lawyers in this space. So there is scope where if you're doing something that is not enforceable in a normal contract, for example, then that will not be legally binding, just as it would if it was an existing legal agreement. So it's yeah, a difficult one to answer. So now that we've seen what the code looks like, we'll have a look at what is the output of that. So the output of that is this string of JSON code, which may look a little bit like a foreign language to anybody who's not a developer, but this is what you get back from the contract effectively. So it gives some state information, who are the parties, and then in this particular case, there's an obligation. So there's a promisor and promisee. So we have an accord party called Steve. This is the promisor. Promisee is Dan. There's also an accord party. There's no deadline specified in this case, but there is a double value of $110 to be paid from Dan to Steve. So that's ultimately where the smart legal contract stops at that point. It will emit an obligation. How that obligation gets processed is outside of the scope of the Accord project and many other legal smart contract frameworks as well. This has to happen. Somebody needs to pay somebody. We can have another clause that will then later listen to see, was somebody paid? And that could be as a result of a bank transfer. And as we said, that doesn't have to be crypto assets. It can be fiat currency as well. So we can check to see if Dan actually did pay Steve. There's no deadline for this in this example. Probably a bad example in this case, because you should normally have a deadline on these things, because otherwise how do you know, there's no immediate urgency. So there can be more work to do in this regard, but this is normally where the external systems get involved. So if an obligation comes out, somebody will be notified, somebody has to get onto accounts, potentially release funds or pay, take money off an invoice or pay something else on top of an invoice. This is where it gets really into the weeds of how these things are deployed in practice. Yeah, maybe a late penalty clause. That's exactly what it is. This is kind of saying, yes, there is a late penalty to be paid, and this is how much it is, and this is from Steve to Dan. So your question is right there. Perfect. It is, this is kind of the contract saying that there is a late penalty clause, but how that gets handled, as I said, is outside the scope of this. So many things can happen to ensure that Steve actually pays Dan, and how does he pay them the right amount? And again, that can be further clauses that need to be enforced afterwards, etc. But that may need to pull into many different types of systems. So the idea of this, again, is producing tech agnostic contracts. So we won't go into all the details of how the parsing works, etc. And that. It was really just to give you a flavor of what are the key aspects for an Accord project, the life cycle of it, and all of the things that you can do, round tripping from templates to contract parameters, and back from, if you've got the contract parameters and the template, you can go back to the instantiation of that. There's lots of different ways to cut it. You can turn PDFs into text and then text into Markdown and so on. So there's lots of different things that you can do in there. We'll have a look at how you can play with this in an online setting and on your own computers in a little while as well. I might stop there and just ask if there's any, now that you've seen a sort of a semi-practical example, are there insurance to protect clients against smart contract malfunctions? Yes, there are, Dennis. In fact, it's a tradable asset class in itself. So it's not one that I've seen for smart legal contracts, although that would be an interesting model. But for smart contracts in general, yes, I forget the name of it. And if anybody knows what it is, please feel free to pitch in. But they will, it normally is dependent on if your smart contract has had an audit, for example. So is it using good practice, like the Open Zeppelin type stuff that was probably covered this morning in your Ethereum example? But there are companies that will provide smart contract liability, yes. So if you get hacked, or if there was a bug in your smart contract code and suddenly the money is stolen, then yes, you can get insurance. And then that in itself, in true crypto fashion, is a tokenized asset. So everybody can kind of hedge their bets and share the risk as well. So I haven't seen it for smart legal contracts specifically, but definitely for Ethereum, it's out there. Don't know for Hyperledger or Corda or anything like that. So I guess it will go back down into any kind of liability insurance that you might have for building any system if you're IBM or Oracle or SAP or somebody rolling out these types of solutions, which are some of the vendors that do. Others are people like Deloitte and ourselves as well. But yeah, very good question on the insurance side. So, hang on. In case of violations of clauses of legal smart contracts, how do the nodes in the blockchain act? Nodes can be contractors, clients, government sponsors, etc. So that is a very good question. In the case of a legal smart contract, that can mean that certain providers might be able to issue requests to certain clauses. So for example, you might have party A and party B being able to execute certain clauses, and then the government or the regulator, or whoever is kind of watching over it, they might be only able to execute certain clauses if they've got the right permission. Not something I've seen in an Accord project example, but something that I've definitely seen in other constructs. So in Ethereum, for example, the owner of a Solidity contract obviously has additional rights, some of which some methods are public, others are not. So you need to have a certain role to execute different pieces of code. In a Corda network, you do have that construct. So the roles are pretty well defined. You might be a notary, you might be just a party to the transaction. A regulator could be another party to that transaction, and you can write it into the contract logic. So if a particular action is being performed, you can have a guard against that to say, well, is this action being performed by a party in this role, for example? So you can write that into the blockchain code, into the smart contract code. But as I mentioned, you could also do something similar inside the smart legal contract. For example, we have the parties defined. So if the party is part of the transaction request, you could check to see if this party is able to actually call that transaction or not. But I would say that that stuff is probably better performed outside of the legal smart contract and enforced at the blockchain level. To be honest, it shouldn't necessarily even get that far to call the smart legal agreement if you're not in the right role. That's specifically why you have the smart contract provisions in there. So proof of work is required to take such actions. Well, not necessarily. It depends again on your flavor of blockchain and proof of work. It's kind of funny, myself and some of the team are also working with CBC at the moment, looking at the impact of proof of work and the real energy consumption. Long story, let's not get into that one, compared a bit with other sort of financial running costs for different sort of fiat environments and other blockchains, but not everything is proof of work. Even Ethereum at the moment is moving away slowly, very slowly, towards partial proof of stake, and there are many other proof of out there, delegated authority, etc. So if we're dealing with private permission networks, so things like Hyperledger and Corda, typically these the proof of work is not an issue because it doesn't use proof of work to secure the network. It uses other consensus mechanisms. But can miners monitor such violations? Absolutely. So that's the whole purpose. For example, in the Corda network, you have the notary, which can keep an eye to make sure that nobody is doing something that they're not supposed to, that they don't have the rights to do, even if they try to do it. So there are different roles in different networks. Yes, they can be miners in some blockchains. They can be notaries in others, or there's different kind of terms, again, depending on your strawberry or vanilla or blackberry flavor of blockchain. But yes, in this example, I would say that should be better left to the environment around the legal smart contract, but you can put those types of construct inside the legal smart contract, although I haven't seen it done. What are the qualifications to become a miner? Again, that's a blockchain question, depending on how this is being deployed. For example, anyone can be a miner really on the Ethereum network. In a Corda network, you don't have miners, but you do have a closed club. So you do need a certificate to be part of the network. It is permissioned in that you need permission to be added. And then you will get added with a particular role. And then depending on how the network is configured, you could validate somebody else's transaction. Sometimes others might do it. Other times you might not see all of the transactions for privacy reasons, etc. So it's really more of a blockchain question as to which flavor of a blockchain you want to use, or do you have miners in general? So yeah, longer conversation. So for generating legal smart contracts, sorry, throat's getting a bit dry here. We have some options. We have a video coming up showing you how to do it on your own machine using command line arguments and JS, etc. But you can do it online using the link below on these slides, which I should have. Maybe you can pop in these slides as well, if possible, or able if you're there. These are the Accord project overview slides, I think. So again, these are public domain. You find different versions of them online at the moment. I think that link might be a little bit wrong down the bottom. The template studio link, I think I don't think you need the V2 link after it at the moment, but it kind of has moved to
which PDF you want to share?
I think it's called Accord Project Overview. That's just if I try and break flow here, it'll take me a while to find it. Thanks, Abel. Yeah. So yeah, I suggest opening up this URL, or just go to github.com, type in Accord Project, and sorry, this is the code behind Template Studio, but sorry, the link to Template Studio is actually on the main Accord project website. You don't need to see the code behind it. My bad. Well, it's not my slide actually, but if you want to see it, you can see it. But the Template Studio is like a playground for going and seeing existing contract clauses that are there, and you can start to play around with those. You can send in requests. You can see what response you get. You can see state changes, etc. So that's your best bet for kind of playing around with the Accord project. I mentioned there's a UI component library if you want to embed it in your own tool. There are some solidity bindings. We're not going to get into that, even though I know you're very keen to do your sort of new solidity your newfound solidity skills, but it's going to take a bit long time to go through that. So videos. I have a video showing you how to get started with developing a kind of contract example, a hello world example on your own machine. There are many, many other videos online on the Accord project. Some of them are on YouTube, many of them are on video as well. And I have some of these listed here as well. So there is one, which is from the middle one here, which is from our recent tech working group call, which Abel was on actually, because I think I'm saying to start between just at about 7:30 minutes in, because there's general kind of housekeeping before then. But I think 30 seconds before that or so, they're talking about this particular workshop and this conference in there. So we're happy to be supporting, and they're happy to be supporting as well. So there's lots of different videos up there. Feel free to just have those. I'm going to talk more because some people are not keen on coding, just judging by the sort of the split in the room. It seems to be only one person claimed to be a developer. So I'm going to keep kind of going through the high level aspects while still not stopping anybody from going through and building one of these themselves. But what we will do is stop in a few minutes and have a discussion around what types of clauses we think we could we could actually automate. Now that we've seen, oh, that's what that is. It doesn't look too complicated. Even if, okay, that code looks scary. I'm not a coder, but that language with figuring out variables or things that can be taken out of a contract, just even starting with that and figuring out what data types they should be, that would be something that could be a useful discussion. Guide to developing installation tools. So if you want to install the tools on your own system with Visual Studio Code, etc., that's all there. Those of you that are interested in Hyperledger, there's a good guide for setting up Hyperledger and how to integrate that with the Accord project as well. We won't be touching that today, just based on time constraints, and also we were going to keep it looking at a Accord example in a little while. But just want to kind of point people in the direction of where to find out more information. So yeah, Dan Selman's been pretty active in this. He's the CTO of Clause and one of the main driving forces. So he's got quite a number of videos that are out there, but there are many others too. How to contribute to the Accord project. If anybody's interested in jumping on board, we'd love to have some contributions. Again, getting things in there, just like any open source project, it's a bit like doing, you have to kind of fork the repository, start a new branch, make your code submissions, push those and generate a pull request for somebody who will review the code and load it back in. It's not as scary as it sounds. We're very happy to help from the CBC side, getting new contributions into our GitHub repository. So very happy to help out on that. Don't be put off by that. If you've got something that's worthy of sharing, it doesn't necessarily have to go through GitHub in the beginning. Let's just use this as a kind of way of sharing that out over the next few days, and feel free to kind of just share it in different ways. Oh, there's our power cut right on time, but the generators are kicking in, so we're all good. Okay, so that is it. The only other thing I would mention on that is the active community on Slack, Twitter, and resources that are out there. So I'm going to stop sharing that one. Time to catch your breath. Any other questions on that specific aspect? So now that you've seen, this is what a contract looks like. This is what the natural language text binds to these variables. These variables can have types, and then we can start to make some calculations or some assumptions about those types and how they relate to each other and how that reflects the intention of the contract. Has anybody got any comments on that? Or maybe we can unmute if anybody wants to make a comment or criticism or an observation. Or would these contracts be gas hungry if transferred to Ethereum? They would be, yeah. It's more, actually, no, yes and no. I think it's not a gas issue specifically why this is not working on Ethereum in on-chain environments. Some of these contracts that you've seen there, they're very, very straightforward, like a late delivery clause. That's not a trivial, sorry, it's not a difficult gas-intensive operation for a Solidity contract, but it could be. If you look, something like an NEC contract, if that entire thing was digitized, that could be quite tricky, but it's not necessarily the gas price is the limiting factor. It's just the fact that Solidity is actually quite limited in some of the aspects of what you can do with it. And some of this stuff that should not necessarily be on chain, and there are various other aspects as to why that would not be the best form of use for doing these things completely on chain. But as I mentioned, newer versions of Ethereum are coming. WASM is sort of the future direction of moving to a more general purpose language, bypassing Solidity and Viper. I think it's the other one, isn't it? I can't remember if Viper is getting any traction at the moment. I haven't seen anything about it in a while. I don't know if it was covered this morning. Does anybody know what's happening with Viper? Yeah,
so apparently Viper is coming back to life because it's Python-esque type of language.
Yeah, that's the one good thing I think it had. It looks like Python, and people are getting more familiar with Python for better or worse. I don't know. I deal with Python on an almost daily basis. It's not my favorite language, but it is very popular.
Yeah.
So how can lawyers with no coding experience interact with code without having to go through a developer? Well, this is for you. This is your starting point. The Accord project is really designed towards trying to help lawyers to get more active and get closer to the code. It's not necessarily going to completely replace a developer, but you've seen that there are kind of 3 layers in there. You might not be writing the Ergo code, but you might be pulling together existing Ergo functions that are there, or assembling the contract and the data model. So you don't necessarily have to get your you get hands dirty with the code necessarily, but there's still a lot of value that you can add beyond just drafting a PDF contract or a Word document contract as a lawyer. That's why the Accord project was specifically designed to kind of not be code first. Start with the contract, start with what lawyers are familiar with, and then break it down into those layers and reuse where possible. So just like you can reuse clauses in a contract, if that contract is executable, tested, contributed and known to be working properly and maybe validated by a regulator. I mean, we were chatting to the Law Society, trying to get them to get more involved in this. Then you can start to assemble contracts which have already been defined. There'll always be customization. This is not going to put you out of a job, I think, in fairness. So lawyers validating contract clauses. Yeah, so definitely there's scope for lawyers to, we have lawyers in-house who are kind of not put off by this, who are willing to try this out and get busy creating some contracts, initially starting in that kind of safe paddling pool of the text, and then gradually moving into data types, and then finally trying different constructs in Ergo and getting frustrated at things not working or breaking, etc. But that's coding for you regardless of the language. Can we convert this coding syntax into an OO language where you can do design objects more easily, like coding C versus coding in Visual Studio? Yes, you can. We have bindings for JavaScript, which is obviously a horrible language in many ways, and not object-oriented in any sense, but you can bind to Java. And from there, Dan Selman has written a very nice UML plugin which can convert your object-oriented code back into a nice UML diagram, if anybody cares about UML anymore. I was teaching a software development course up to a couple of years ago, and it's kind of amazing how, not that UML was ever that broadly used, I think, but it is very useful, and I am a fan of it in certain contexts to illustrate the complexity of a system without having to be, without having to get a complete understanding of how it works, but just by looking at the code and the documentation. Because let's face it, the documentation and the code don't always align. So yes, you can export the current state of what is the code, and it will spit out, just like you could with IntelliJ, for example. We'll have a look at a little bit later with Corda. It has a, I can't remember if it's Plant UML or Argo UML, but it's got a plugin for generating these types of classes from there. So yes, you can convert the syntax into an OO language like Java. And that's exactly what happens in the Corda example, as we'll see a little bit later. Okay, right, time to open it up now for any suggestions on clauses that people would like to kind of start to automate or start to discuss in more detail. And maybe we can share a few examples. People can pop up an example of a clause and maybe we can use it as a discussion point. I started with the late delivery and penalty, but there's many more types of clauses that are out there. Maybe you've had a chance to have a look at the Accord Template Studio, and maybe there are some clauses there that might be of use. Anybody? Liquidated damages. I only found out what that was properly last night myself, actually. So from getting feedback from Tom Grogan on some of the words penalties apparently is not the correct term to use in this particular case. So liquidated damages are the correct term. So yes, I only kind of started seeing the subtle difference between the two last night. Again, not a lawyer, different type of language. I know many different programming languages, but certainly I think legalese is one of the more complex ones I've had to try to review. Final and binding power, tender bid. All right, keep them coming in. Again, these will mean far more to you and the people on the calls. But maybe if you have an example of a short extract that you can paste in, that's not, obviously there's licensing concerns and IP and various other things. Extension of time request acceleration. Hit the client doesn't pay, then hit the man around the house. Yeah, I might have to put a clause like that in. Myself, at somebody who's supposed to be fixing a boiler for a house for me in Ireland, that's out of action for the last week. I could potentially, I know my tenant who's living there could potentially send somebody around to give someone a smack at the moment. Disruption clauses, performance security, permits to start work. Yeah. Okay, quite a few in there. Some interesting ones. The extension of time request, I think, sounds interesting because that is aligned, let's say, with the late delivery penalty. Sounds like one that could be kind of adapted relatively easily. Although these things are never that easy when you see all of the, the legal language behind it. A full tender bid, that's a bit more tricky, I guess, but I suppose you could have some kind of a clause with looking at, who's putting in the tender and ensuring that it's a fair auction price, for example. So you can do that with smart contracts at the moment. There's also once they bid for it, do they actually deliver at the price that they have popped in, and then the payment is based on the original tender, etc. So you can start to pop in things like that. Yeah, work completion certification. Now, that is definitely one that we've looked at, and we had a discussion with ARP and EHAB actually originally, before they started looking at the weather stuff, as to how can you determine if something has been completed according to satisfaction. So payment notices and serving notice, yeah, these all sound very, very good. Third-party quality assurance, yeah, absolutely. So all good stuff and all things I think that we should be capable of, well, not all, I would say I'd need to find out a little bit more details on some of them, but certainly some of these clauses sound like they could be something that we could work towards. So we could do with maybe a snapshot or a little kind of example of what a clause might look like, if anybody's willing to maybe pop that into the chat there. We can start to maybe brainstorm around a clause collectively. Like I said, I have a canvas for this purpose, which we can talk about in a few minutes as a kind of a starting point. But before we get to that more structured way of doing things, then maybe let's have a look at just kind of popping these in. So we have what, at least 10, 12 different clauses inside there. Is anybody willing to kind of pop in if they have like a very simple, if there are, so let's start small, one paragraph or so, which might be an executable clause potentially. And we can start to see how that might map to an Accord project template. Not to worry, we can have a look at that. Let me share, I don't think I sent this on Able as a PDF, but I can dig it out in a moment, which is the Smart Legal canvas, just the PNG file, not the full. It's in this one of the slide decks, but it got a little bit squished, etc. So we can share that round, and people can look at that, and once they have a clause in mind and think about the various different issues. But before we get to that, let's even just start with a simple clause that maybe we can, if somebody can pop in, and then we can start to populate collectively, crowdsource what they think would be, how they could extract that from a clause, and then what type of data it might be, and then sort of data type it might be. And then maybe without getting to full Ergo, we could start to have a look at some pseudocode in whatever language you might be interested in, whether that's structured English, COBOL, Fortran, or sort of something more modern like Python or Java, JavaScript, whatever, anything that has a bit of logic in it and what needs to happen. Maybe we can start to look at that, because if you can't do it in old-fashioned English, it's going to be very difficult to do it in code. Okay, good question coming in there about if you already have a paper-based contract, is there a way to automatically convert it to a smart contract? So what I suggested there in the past was, if you have a binding legal agreement with somebody, then already you have an agreement. There would be an argument also as to which one is, if you have two versions of the same contract, one of them might be more in your favor, one of them might not. So which one is actually binding? That's more of a question for a lawyer. But if you were to take the example that you just want to automate an existing vendor agreement that you have, to make it actually executable, you would need to prove that that agreement was actually signed sort of on chain effectively as well. So what I've said was, you probably need to go back to who you signed the agreement with, and both of you would need to kind of agree that this contract or this representation of the contract is now electronic. Which one overwrites, in the event of a dispute or a problem? Is it the electronic one or is it the paper one? that you're going to respect. So that's your first practical problem. And then yes, can you automate all of the contract? If you can, are you happy the way it's been automated? Are both parties who signed that agreement happy that this electronic version of it implements the same agreement, the same terms, and then they'll have to both agree to it being deployed electronically. Yeah. Cool. I couldn't remember if I popped that up or not, Abel. So yeah, I think legal smart contracts, that PNG, if you can pop that up there. So this is my attempt at putting together a canvas for kind of brainstorming these types of things. Let me show you what that looks like. Just in some slides. Let me share my, well, actually, let's get it running first in PowerPoint, because that might inspire some thought. So we can take one of these as an example, and rather than jumping straight to the code, we can start with some type of design first, which all good developers are supposed to do, but I guess rarely do in practice. But in particular, I think for blockchain, there is a good motivation for getting things right and to ensure that things are working, because when you start to put these things on chain, it can't be changed. So yeah, definitely, I think it's important to get these things right. The amounts payable to the contractor and valued at base rates and prices shall be adjusted in respect to the rise and fall of index cost of labor, materials, by addition of subtraction of amounts. Okay, that sounds like an interesting contract. Lots going on there, lots of inputs to that contract. The tricky bit there is, where does the data come from? And is it fixed during the life cycle of the contract, or is it dependent on external variables? So this to me sounds like something that would be a classic Oracle example. So something that needs to come from an independent third party, which indicates what the price of labor and materials is. And that needs to be agreed by everybody. Obviously, either a buyer, seller, or contractor or client's favor, to give different versions of what those costs are. So having a neutral third party that's doesn't have skin in the game is potentially a good way to kind of get that data into the smart legal agreement. So that could be published, by different industry groups, or maybe it's a government figure. You could, let's say, something like the inflation rate, for example, is publicly available. But how do you can't just type that in. You need to ensure that you've got it from the government website, and that's where, when we start to get into blockchain oracles, you can start to look at tracing the provenance of that data from provider all the way through to on-chain and then into the smart legal agreement. So you have to show where that kind of data came from to make sure that people aren't trying to pull a fast one, etc.